When we solve an equation, a quadratic equation, by completing the square, we first need to make sure we put the equation into ax squared plus bx equals c form. Very important that you write down all these steps. We're going to move the constant to the other side, and we're going to have the quadratic term plus the linear term equals the constant. Then we're going to find half of the coefficient of the linear term. So whatever the coefficient of the linear term is, we're going to cut it in half, and then we're going to square it. Step 3, we're going to complete the square by adding the value found in step 2 to both sides. So we will add that value that we found in step 2 to both sides. After that, we'll be able to factor the quadratic to be a binomial squared, either x plus that value found in step 2 squared, or x minus that value found in step 2 squared. That plus or minus is completely dependent on whether or not the linear term, the bx term, which is your linear term, whether or not that's positive or negative. So let's try this out. X squared minus 10x plus 7 equals 0. We're going to solve this by completing the square. Our first step says to put this equation into x squared, ax squared plus bx equals a constant. So we're going to put it in this form. Now when I write this, I'm going to leave myself a little bit of room right here, because what I need to do is I need to find half of this term, so half of this linear coefficient. So the linear coefficient is negative 10. Half of that is 5. 5 squared is 25. If I add 25 on the left-hand side of the equation, I need to add 25 on the right-hand side of the equation. That gives me x squared minus 10x plus 25 equals 18. Now what we've done is we've created this trinomial that is a perfect square trinomial. You might recall this from factoring. This factors to be x minus 5 times x minus 5, which we can rewrite as x minus 5 quantity squared. Now this is perfectly set up for the square root method. So now that we have created a perfect square trinomial, that's called completing the square, we now can square root both sides, giving us x minus 5 equals plus or minus the square root of 18. Now the square root of 18 is 3 times the square root of 2. So we have x minus 5 equals positive 3 times the square root of 2. X minus 5 equals positive 3 times the square root of 2. Or I should have done x plus 5 and then x minus 5. It doesn't really matter, but I like to go with the positive first since it's on top of that negative. X plus 5 times, yeah, I messed that up. They're both going to be x minus 5. This is going to be positive. So here's my positive right here. And here's the negative. Negative, negative. 3 times the square root of 2. In fact, I'm going to rewrite that again. If you know where I made my mistake, then you are in a perfect position. But if that confused you a little bit, I'm going to backtrack. I'm going to show all my work. X minus 5 equals plus or minus 3 times the square root of 2. Now I'm going to create an equation with the positive. So x minus 5 equals 3 times the square root of 2. And I'm going to create an equation with the negative. X minus 5 equals negative 3 times the square root of 2. We'll add 5 to both sides, and we get x equals 5 plus 3 times the square root of 2, and x equals 5 minus 3 times the square root of 2. Now these values, 3 times the square root of 2, are connected by multiplication. You'd have to do that multiplication before you can add. So our answer just remains 5 plus 3 times the square root of 2 and 5 minus 3 times the square root of 2. And those are our two solutions. Some people will write them like this: x equals 5 plus or minus 3 times the square root of 2, and that is also allowed. So here's one for you to try. If you feel comfortable trying this problem, that's great. If you don't feel comfortable, I'm going to work it out, and you can follow along. First thing I'm going to do is I'm going to rewrite the equation, leaving room to complete the square, and adding 9 to both sides. I'm going to cut the coefficient of the middle term, the linear term, in half. So that's a 9. 9 squared is 81. Adding 81 to the left means I have to add 81 on the right-hand side of the equation. And then my perfect square trinomial factors to be x plus 9 quantity squared. This 9 falls right into place. And that is equal to 90. Now I'm going to break 90 down: 245, 315, 35. So I have 9 times 10. The square root of 9 is 3. And then I'm going to have a 10 left over. So when I square root both sides, I have x plus 9 equals plus or minus 3 times the square root of 10. I'm going to subtract 9 from both sides. Again, that 3 and the square root of 10 are connected by multiplication. So this is our answer. However, I am going to write it out because it's not a bad habit to understand and to visually see these two answers written out. I'm going to try and do a better job of making boxing this. Not too bad. Those are our two answers. So hopefully you got those answers and you're feeling somewhat comfortable with completing the square.